Hey guys, we are going to be doing a stoichiometry problem. Now, stoichiometry is a long, complicated word that means that you analyze a chemical equation according to how much of the reactants are put in, so like how much of the ingredients you have, and then also how much of the products you get out. Although in stoichiometry, the in-between steps are usually calculated in moles, a lot of the time the desired output is in terms of grams. So we're going to have to practice a couple of things along the way. Namely, we're going to have to be able to comfortably convert between grams and moles, which of course has a different factor for different substances. We're going to need we're going to need a balanced equation, and we're also going to need to understand the concept of a limiting reactant. Let's get started. We've got calcium carbide, which reacts with water to form calcium hydroxide and acetylene gas. The first step is to balance the equation. You can't do anything here unless you have a balanced equation, because that tells you, like, this many moles of this many moles of this. Thankfully, this equation is going to be pretty easy to get. So I will, first of all, just write a quick version of this equation. Calcium carbide is CaC2, and that reacts with water, so that's plus H2O. And this yields calcium hydroxide. Now, stop and think for a second. What is calcium hydroxide? Calcium is Ca. Hydroxide is a polyatomic ion. You have a handout from your class that tells you that hydroxide is OH, and that's an ionic compound because OH is a polyatomic ion. So Ca has a +2 charge, or you write it as 2 plus, and OH has a -1 charge. That means that there need to be 2 of these to balance out with the 1 of the calcium. Now, I'm only writing these as a shorthand. When you actually go to write the chemical formula, you always, every time, just write how many there are of each. You never end up writing the charges in the chemical formula. The other product here is acetylene gas. That's C2, H2. Of course, balancing the equation doesn't involve just writing the things down. It involves getting the right numbers of each one of them. I'm going to keep track of the different things in this equation and say, do they balance on the left and on the right? On the left and on the right. Right now, there is 1 calcium, there are 2 carbons, there are 2 hydrogens, and there's 1 oxygen on the left. On the right, you have 1 calcium, so that seems like it's already pretty much all set. There are 2 carbons, so far so good. The hydrogens, however, are not yet balanced because you have 2 of them on the right from that term, and then you have 2 more from that term. So that's going to end up giving you 4 total hydrogens on the right. So this is our first unbalanced thing. It doesn't mean we made a mistake in writing the equation. It just means we've got to do some work to balance it out. The oxygens have 2 based on this. The 2 on the outside of the set of parentheses means that everything on the inside gets doubled. So there were 2 oxygens and 2 hydrogens there. Okay, so now we've got 2 here. You might be able to see what we're going to do to fix this. We need to fix the imbalance here between the hydrogens, and we also need to fix the imbalance here between the oxygens. But look at what we can do. There's something where we can fix both problems at the same time by putting a 2 in front of the H2O. That will double the hydrogens to make 4 on the left, which fixes the problem. It will also double the oxygens on the left to make 2, which fixes the problem for the oxygens as well. So with the 2 there, now this is fully balanced. So that I can have space to write, I'm going to put this in. I'll put CaC2 plus 2 H2O yields CaOH 2 plus C2H2. Notice how the only thing that needed any numbers to fix this is the hydrogen. I'm sorry, the water to fix the hydrogen and the oxygen. With this inserted now, we have fixed the problem because now there are 4 hydrogens on the left and 2 oxygens. So far, so good. Okay, so how I'm going to structure this is I'm going to write a bunch of stuff by hand, but then get the answer typed down so I can erase everything. So, ba-bing. So now that answer is down. What's next? If this reaction will run with 175 grams of calcium carbide and just enough water to completely react, how much water will be required and how much of each product will be produced? State all answers in grams. Now, up here, I've put a category for useful info. For this, I'm going to go and grab all of the atomic masses for these things. And don't worry, I'll do it in a way that you can follow along. Let's see, we've got calcium, which has an atomic mass of 40.078. I'm getting that right here. You can find this anywhere on the internet. There are billions and billions of periodic tables, and you probably have one from your class as well. 40.078. I'll write these down separately so I don't have to keep on going back. 40.078. Carbon is 12.011. Hydrogen is 1.007. I think your class says 1.0079. And then oxygen is 15.999. The mathematician in me always wants to go, come on, that's 16. But no, we're going to actually call it 15.999. So I'm going to get that down here. Calcium is 40.078 grams per mole. Carbon is 12.011 grams per mole. Hydrogen is 1.0079 grams per mole. And oxygen is 15.999 grams per mole. Okay, so what this is going to let us get is the molar masses of all of the reactants and all of the products here. So the calcium carbide is going to be 1 copy of the 40.078 plus 2 copies of the 12.011. And instead of stopping to do calculator over and over, I'll get the bunch of calculations and do them all at once. So now the H2O. Notice how I'm not putting a 2 in front of it. I'm just interested in its molar mass by itself. The H2O is going to be 2 copies of hydrogen, 1.0079, and then plus just 1 copy of the 15.999. If you don't write the 1s here, that's fine. Don't worry about it. It's the same result. I'm just being like super particular about this, just so that I make sure I have all the details down. Basically, if you're getting it right, then don't let anybody tell you you're getting it wrong. If the 1 is not there, you're still getting the same answer and it makes sense. So if somebody tells you that's wrong, you just ignore that person. So calcium would be 1 times 40.078. And then plus here, I need to make sure that this entire thing gets doubled. The hydroxide is going to get doubled in its entirety. So what I'm going to do is put a 2, and then I'll open a set of parentheses, and I'll add together the oxygen and the hydrogen on the inside. Hopefully it's clear that this right here, this 2 copies of that is meant to refer to the 2 copies of the hydroxide. One more, I've got the C2H2, and this will be 2 copies of the carbon, 12.011, plus 2 copies of the hydrogen. And now it is magical calculator time. Hopefully we all brought our brains today. 40.078 plus 2 times 12.0 0.11. This is 64.1. Huh, that's really interesting. It actually lost the other decimal places because they combined to zero out. So I want to keep track of the units here. This is grams per mole, okay? H2O is 2 times 1.0079 plus 1 times 15.999, 18.0148. Calcium hydroxide, 40.078 plus 2 times 15.999 plus 1.0079. And this is 74.0918 grams per mole. And then finally, 2 times 12.011 plus 2 times 1.0079 is 26.0378. Okay, I'm going to categorize these as part of my useful info. That means that I'll get calcium carbide. By the way, to get a subscript in Google Docs on a Mac, hold the Command key and hit comma. That brings you into subscript mode. So watch this. Bing! Now I'm in subscript mode. That was because I held Command and hit comma. And then if you do it again, it brings you out of it, which is really nice. It's convenient for writing these chemical formulas. So calcium carbide, that will be 64.1 grams per mole. The water is 18.0148 grams per mole. Calcium hydroxide is 74.0918 grams per mole, because I can read my own handwriting, even though it's terrible today. C2H2 is 26.0378 grams per mole. Okay, why did I get all of those? It's because the ingredients here are stated in grams. If this reaction is run with 175 grams of calcium carbide, I need to be able to turn that into moles, because all the in-between steps are going to be moles. Everything in chemistry is moles, 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 moles. So grams are nice because that's what you can put on a scale. But to do chemistry analysis, you need to turn those grams into moles. And the molar mass is what links together grams and moles. So now I'm going to be able to say calcium carbide grams to moles. That's going to be 175 grams of calcium carbide times, and now this is where the magic comes in, because this is the equivalence between the grams and the moles. I want to put grams on the bottom and moles on the top. Generally, when you're using a molar mass, the moles are on the top and the grams are on the bottom. This is calcium carbide, so I'm going to be grabbing this number from right here. 64.1 grams is the same as 1 mole. Why can I multiply that? Why can I multiply by this? It's because as long as I'm in calcium carbide land, then 1 mole is the exact same thing as 64.1 grams. And so this fraction right here is equal to 1. This means I'm performing the same action here as if I'm finding a common denominator in math, multiplying by like 3/3 or 5/5 or something. That doesn't change the quantity you're talking about. It just changes the way that you write it. So now we're going to get this 175 grams of calcium carbide, and the same way that we might convert 2/3 into sixths by multiplying by 2/2, now we're timesing by 1 mole over 64.1 grams. That's going to allow us to write this very same quantity of 175 grams of calcium carbide, but now in moles instead. Here it is very explicitly. The grams as a unit cancel. And this 175 gets divided by 64.1 to get 2.73 moles of calcium carbide. Okay, this lets us do a whole bunch of easy stuff now, because this says just enough water to completely react. Well, how much water is that? Now, trust me, it's about to get easy. 2.73 moles of calcium carbide times, and now I'm going to use a conversion factor that comes from the chemical equation. I want to replace moles of calcium carbide with moles of water. According to the equation, in this reaction, for each 2 moles of water, you have 1 mole of calcium carbide. See how it's another conversion. The 2.73 moles of calcium carbide, according to this equation, is equivalent to a certain number of moles of water. To find out what that number is, you multiply by another conversion factor that's equal to 1 for this specific circumstance. Just like 1 mole over 64.1 grams was equal to 1, as long as we were talking about calcium carbide, 2 moles of water is the same thing as 1 mole of calcium carbide. And so this fraction is equal to 1 as long as we're talking about this reaction. The arithmetic is easy. You multiply by 2. The units cancel, and you don't even need a calculator for this one. It's 5.46 moles of water. Okay, and now I'm going to turn that into grams of water. And again, I'll do that by using the molar mass. I'm going to go a little faster this time because we've already seen it. Put moles of water on the bottom and grams of water on the top. We know the molar mass. It is 18.0148. And that's equivalent to 1 mole. So this equals, let's see, 5.46 times 18.0148. That's 98.36 grams of water. Okay, so this says how much water will be required. We've got an answer for that. We've got 98.36 grams of water, H2O, will be required. The second part of this question says how much of each product will be produced. Okay, well, for this, I'm going to get rid of all this junk. And you know how I converted the 2.73 moles of calcium carbide into moles of water? Well, I'm going to do the same thing, except now I'll do it for the product side. So 2.73 moles of calcium carbide is going to now get multiplied by another conversion factor. I want moles of calcium carbide to go away, so that goes on the bottom. Moles of, let me see, I'll do the calcium hydroxide. And the equation tells me that these happen in a 1-to-1 ratio. I'm even going to really go for the gold and turn this all the way into grams in a single calculation. Yes, you can do this. Moles of calcium hydroxide on the bottom, and then grams of calcium hydroxide on the top. I know that 1 mole of calcium hydroxide is the same as 74.0918 grams. And this is multiplication now. I know that moles of calcium carbide go away. And now moles of calcium hydroxide go away, meaning that the unit is what I want. It ends up being grams of calcium hydroxide. So 2.73 times 1 and then times 74.0918 divided by 1 and then divided by 1. Well, I don't really need to do any division. So it's just 2.73 times 74.0918, which is 202.27 grams of calcium hydroxide. And I'll put that in. 202.27 grams of calcium hydroxide is produced. And, well, now, what do I put in at this point? I'm going to go for the other product. I'll do the 2.73 moles of calcium carbide. Again, I'm going to convert it. Moles of calcium carbide is going to get replaced with moles of the other product, which is the acetylene. This is the C2H2. the reaction tells me that these occur in a 1-to-1 ratio. So this is 1-to-1. Again, go for the gold, do all the conversions at once, and moles of acetylene replaced with grams of acetylene is going to get you everything you need. Let's see. So now we need the molar mass of the acetylene. We got that up above. It's right here. 26.0378 is the same as 1 mole. The units, bum, 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 those cancel very nicely because this is just so awesome. And the only multiplication left to do is 2.73 times 26.0378, 71.08 grams of acetylene gas. Okay, so 71.08 grams of acetylene. I'm going to make a mark right here. 175.0 grams of calcium carbide is 2.73 moles. That way I don't have to have it written down. Okay. The next part, part C, says if 175 grams of calcium carbide is used just as in part B, but double the required amount of water is used, no additional products will be made. Explain why. Here's the deal. The calcium carbide, if there's more of it, but there isn't more water to react with it, it can't go anywhere. It can't do anything. So the answer to this one is going to be that if there is more water, then calcium carbide is, well, not still, but is now the limiting reactant. The reaction will only proceed as far as it allows. When, because I can type, when calcium carbide runs out, it doesn't matter if there is more water left over. Think about making peanut butter sandwiches. If you have lots of peanut butter left over, but are out of bread, you can't make sandwiches anymore, even though you have lots of peanut butter. So that's kind of a cutesy example. If 58 grams of calcium carbide is used in the reaction, is it possible to yield 100 grams of calcium hydroxide? So let's look at this. 58 grams of calcium carbide. And the question is it possible to yield 100 grams of calcium hydroxide? I'm going to convert this first into moles. So grams of calcium carbide and moles of calcium carbide. Those units will obviously cancel. Now I'm using the molar mass of the calcium carbide. That's 64.1. So those are going to cancel again. Go for the gold, do all the conversions at once. Now I want to turn moles of calcium carbide into, let's see, moles of calcium hydroxide. And again, the reaction tells me that these occur in a 1-to-1 ratio. And then go for the super gold and convert that all the way into grams, because the question is it possible to get 100 grams of calcium hydroxide? Well, I'm going to put moles of calcium hydroxide on the bottom here, and then convert that into grams. This I'm going to use the molar mass for. The molar mass for this is 74.0918 over 1. And when I perform all these multiplications and divisions, I'm going to get 58 times 74.0918, and then divided by 64.1. That gets me 67.04 grams of calcium hydroxide. In other words, Once all the 58 grams of calcium carbide have been consumed, they've been used, they're gone, we don't have any more of it, we've done as much as we can, and we've made 67.04 grams of calcium hydroxide. And we're done. We can't make any more. This is like running out of bread. You can't make any more peanut butter sandwiches because even though you have lots of peanut butter left over, it's impossible. You ran out of a thing that you need in order to make it. So the question was, if 58 grams of calcium carbide is used in the reaction, is it possible to yield 100 grams of calcium hydroxide? The answer is no. It is not possible, since the 58 grams of calcium carbide will run out before 100 grams of calcium hydroxide is produced. Only 67.04 grams will be produced. You usually want to give some evidence that you worked out the actual answer instead of just taking a guess and hoping that you're right. So this is how you answer this question all the way down to the bottom. So this says, if not, explain why it is not possible. This is an explanation. The 58 grams of calcium carbide will run out when only 67.04 grams will have been produced. Another way of stating this is that the calcium carbide in this sense will be the, well, not the limiting reactant, because we didn't say how much water would be present, but no matter how much water you have, it's not going to be possible to make more than the 67.04 grams because you'll run out of it and then you can't run it anymore. So that's how you do a big, long stoichiometry problem, and I will see you next time.